Hey everyone, welcome back. This lecture will cover the first part of Chapter 1. After you finish this, you will complete a short assignment and then proceed to the second part of Chapter 1. So Chapter 1 is Introduction to the Earth. We're first going to start a little bit about what is geography in the first place. So geography is the study of the Earth and the way we interact with it, and much, much, much more. One of the reasons I chose to be a geographer was that it allowed me to do so much, to mix physical geography, which is what we're going to talk about in this class, with cultural geography, which I also love. So some geographic concepts that we as geographers use to think and look at the world and explain certain phenomena, and we'll go through each one of these separately, but they are location, space, place, human environment interaction, movement and networks, systems, and scale. So first, location. We have two types of location. We have absolute location and relative location. So with absolute location, which is what our phones use very often, right? It will give us an exact pinpoint on the planet, on the planet that will explain where we are. As opposed to relative location, we are in Southern California. That's a relative location, right? So is the South or the Midwest. These are kind of locations that are in relation to something else, but don't give you this exact absolute location on the surface of the planet. The next is space. Geographers want to know why things fill up certain spaces and certain patterns. And so this is something that you'd be more likely to look at in a cultural geography class. But here's a racial dot map of Detroit. And you can see that it's quite segregated. You have most of those green dots being an African American population, as opposed to the blue dots, which are mostly white. And you can see there's an Asian population kind of right in the middle. So as geographers, we want to look back and say, hey, why is this city so segregated? Why are certain people living in certain places? The next thing is place. And place is kind of more of a feeling or connotation, right? There's different types of places that we can talk about that we can have attachment to or can provide different meaning to. So for example, the South, right? When we talk in the United States about the South, we may think of things like negative things like slavery. We may think of good home cooking or nice weather. My parents live in Florida, which is part of the South. San Diego has its own kind of cultural connotations with the beach and surfing and palm trees. The city, that's a place, right? The city is very different from the country. When somebody says the word the city, you can think of some specific aspects of it. Home, that's a place, which means a little bit different to different people. Facebook is a virtual place, right? We post things on your wall, right? It's this virtual place. Places like Skyrim, right? Video games do a lot to create very vivid places for us. And finally, the ghetto, right? The ghetto, when we hear that word, we can think of all different aspects of what we believe a ghetto to be. Human environment interaction, that's mostly looking at kind of how we are affecting the environment and how sometimes the environment is affecting us. So for example, you might recognize this picture. This is a picture of industrial agriculture where we're spreading pesticides onto a field. And when we spread pesticides onto a field, especially at a large scale, when it rains, some of that pesticides, but also fertilizer, is going to run off into local waterways. And when you have fertilizer that runs into local waterways, that fertilizer can feed algae that can grow out of control. And so you kind of get these greenish bodies of water. And then that can lead fish to die because they can't handle all the algae that's in the water. And then subsequently, that can affect fishermen downstream. So we can look at how we're affecting an environment and how the environment is affecting us. When we think about movements and networks, this is a picture of people migrating through Mexico on top of the train on the way to the United States. This picture was taken a couple of years ago during the crisis of having so many undocumented minors entering the US that were mostly fleeing Central America. And so we want to think about how do things and people move throughout the environment? Why do they move? How does that shape the connections and separations between places and people? We also look at systems. We're going to spend a decent amount of time in this class looking at systems. This is a glacier system, which will be one of the last chapters that we cover. So physical systems, physical science looks at systems, inputs and outputs, and interactions of matter and energy, right? So how do glaciers form? How do they move? You can see there the material input is snow and ice. You have an energy input of solar radiation that's helping melt it and push it down a hill. And we'll talk a lot about systems in this class. And then scale, right? So we want to know the phenomena that we're looking at. Are we looking at it at the right scale? Is it a global issue or a local issue? When we think about politics, which I'm sure a lot of us has been thinking about politics lately, is this a California issue or is this an issue at the level of the federal government? And when we look at maps, we want to make sure that we're looking at the right scale. And we'll talk more about scale in chapter 2. So again, geography covers a lot of different things. So cultural geography can look at economics, language, religion, political systems, settlements, food. Physical geography, which is what we look at in this class, is going to look at landforms, rocks, minerals, water, weather and climate, plants, animals, and soil. And so it's that mixing of natural science and social science. In my research, I've used both, which is one of the reasons why I love geography. We will touch on some aspects of cultural geography in this class, but it is a physical geography class. We'll be mostly looking at that physical geography. And so again, when we look at systems, right, we want to make sure that we know what we're talking about because we are going to look at a lot of systems in this class. You can look at, in this picture, you can see the atmosphere. That's its own system. The cryosphere we're not going to talk about in this class, but the lithosphere, we're going to look at landform study. The biosphere, we're going to look at biodiversity. The hydrosphere, we're going to look at how water moves throughout the system. So we want to start to think of the Earth as an object, right? We are studying this object, the Earth, our planet. It is not a sphere, a perfect sphere, but it is pretty close. It's pretty diverse, right? We have really high mountains, such as with Mount Everest at over 29,000 feet, very deep trenches. The Mariana Trench goes down to 36,000 feet below sea level. That gives us a total difference in elevation of loan of over 65,000 feet. So quite a varied topography. And we can see here that the Earth has two poles, as the North Pole and the South Pole, and we tend to divide our Earth into different sections. So if you can think about slicing it right through the North and South Pole and then right across the equator. And we're going to talk about these because we use these as the basis for latitude and longitude. Which I will explain in just a second. So latitude and longitude are coordinate systems that we use to identify exactly where we are on the planet. And so it's really easy to get these two confused. I like to think of latitude being associated with a ladder, right? That's where we'd kind of crawl up and down the Earth, as opposed to longitude. They serve, really, together they let us know where we are on the planet, but they serve very different purposes. But together they make this nice grid that lets us know exactly where we are on the planet. It's a great system. And in this class, we're going to talk not about decimal latitude and longitude. We're going to use the kind of old-fashioned north, south, east, west, which I'll go into in just a second. So first, we're going to talk about latitude. Latitude is how far north or south something is from the equator. This divides the northern hemisphere and the southern hemispheres. Latitude is divided into degrees. So it goes up to 90 degrees north and 90 degrees south. Those degrees are divided then into minutes and seconds. So when we see, we'll look at some kind of very precise latitude coordinates, and they will have minutes and seconds as well. So again, 0 to 90. You're not going to have, there's never a latitude that is going to be 91 degrees, right? It's going to go from 0 to 90, and that differs from longitude. The lines of latitude are called parallels, And that's because all up and down, they run parallel to one another. They never get closer together. Oops. They never get closer together. They just run parallel to one another. And why is latitude significant? Lower latitudes are warmer. So anything with a lower number is going to be closer to the equator. Higher latitudes are going to be colder. Anything with a higher latitude is going to be farther away from that equator. And we all kind of colloquially know, hopefully, that the equator is a very warm place, right? It's very tropical, it's very warm, as opposed to the Arctic, which is very, very cold, which is at a high latitude. High does not equal north. It means far from the equator. And we want to make sure that we remember that because there are very cold places in the southern hemisphere, which we'll talk about. Antarctica is at a very high latitude, but it is south of the equator. Here is a picture from when the World Cup was in South Africa during our summer, which is their winter. And this is a little boy blowing an instrument called a vuvuzela. But there were a lot of comments on Twitter during the World Cup saying, why is he so bundled up? Like, it's so cold. And that's because it was their winter, right? It doesn't, just because you're in the southern hemisphere does not mean it's not going to get cold. The farther you get away from that equator, the colder it's going to get. So again, here's another map looking at kind of the longitude and latitude. Your assignment after the first part of chapter 1, which is going to be exercise 2, you're going to do a very simple, answer a few simple questions looking at a blank map, talking about latitude and longitude. So again, if we know something about the latitude, we can know something about that place, not everything, right? If you know the approximate latitude of a couple of places, so San Diego is 33 degrees north. We know what the weather looks like in San Diego. There it is right there with that red dot. Portland, Oregon is 45 degrees north. And there you go, you can see right there. Most of us know, unless we're new to the United States, that Portland is colder than San Diego. Anchorage, Alaska is 61 degrees north, and there it is right up there. Much, much colder than San Diego, right? So using our own latitude, which we now know is 33 degrees north, we can kind of make some types of inference about what weather is like in other places. So you can use what you know to infer about other places. Other places around the world that are about 33 degrees north are going to have, they're not going to be freezing temperatures, right? And they're not going to be super, super warm either. There's a lot of other things that go into weather and climate, and we'll talk about those as the semester goes on, but latitude is one of those good indicators, right? So if we look at this map here, we see a place that is 12 degrees south of the equator. And you could say, well, what does this place look like, right? 12 degrees is pretty close to the equator, so we can say that this place is probably going to be pretty hot. It's on the ocean. This is Lima, Peru. It's a pretty balmy place, right? Pretty warm there. Some significant latitudes that you want to remember. So the equator is at 0 degrees. And then the Tropic of Cancer and the Tropic of Capricorn are at 23.5 degrees north and south, respectively. And we'll talk about later in chapter 1 why those are so important. And then the Arctic Circle and the Antarctic Circle are at 66.5 degrees north and south, respectively. And then the North and South Pole are 90 degrees. And so again, just remembering that with latitude, it's never going to be higher than 90 degrees. Longitude is different, right? Longitude is how far or east or west of something is than the prime meridian. That picture in the bottom right, that's where the prime meridian is running through Greenwich, England. Unlike the equator, which is designated as a specific place for specific physical geographic regions, the prime meridian could have really been designated anywhere. And historically, there were actually multiple prime meridians. But then as people started to globalize and talk to one another, we realized we needed one prime meridian, and it won out in England. England colonized a lot of the planet, so it got to have the prime meridian. So the prime meridian divides the eastern and western hemispheres. And it's divided into degrees, minutes, and seconds, just like latitude is. But this goes from 0 to 180. So unlike latitude that only goes from 0 to 90, longitude goes from 0 to 180 degrees. And these lines are called meridians. They're not called parallels like latitude because they do not run parallel to each other the entire way around the globe. You can see at the picture on the bottom left that meridians actually get closer to one another as they converge at the poles. They are not parallel. So how is longitude significant? It's not really. It's kind of arbitrary. It does not tell us anything fundamental about that place. If you know the longitude of a place, you're not going to be able to say anything about the weather or the climate. You're just going to be able to say where it is. It loosely determines the time zones, but not definitively, because we do that based upon the borders. The US here, we have 4, well really 5, 6 time zones when you get into Hawaii and Alaska. China is quite a big country, and China is all on one time zone because they have decided as a country that that's how they do. They want all one time zone. In the US, our time zones, right, you change a time zone, generally speaking, when you cross a state line, but they're loosely based on that, but it's pretty arbitrary. But it helps form that grid with latitude that gives us that specific location on the planet. And so we want to think about longitude and latitude as that grid system. Again, if we look at San Diego is 32 degrees 43 minutes north and 117 degrees 10 minutes west. And so with that, we can find out exactly where we are on this system. That globe you see there is showing you where the northwest, northeast, southwest, and southeast quadrants are. Here's the California State Capitol building in that picture right there, and we can get pretty darn specific. 38 degrees, 34 minutes, 35.98 seconds north, and 121 degrees, 29 minutes, 37.06 seconds west is the tip of the dome of the state capitol. So we can get very, very specific with our exact location. Our phones use a GPS coordinate system that's based upon longitude and latitude. The numbers look very differently, but this system allows us to pinpoint an exact location on the planet, and it's pretty darn handy. So again, here's a map showing loosely that longitude and latitude. So you're looking at North America is in the northern and western hemisphere. Europe and most of Europe and Asia and Africa are in the eastern northern hemisphere. Southern hemisphere has a decent portion of Africa, Australia, and Antarctica. South America is mostly in the southern hemisphere, but not entirely. So we're going to end our lecture there. When we come back, we're going to talk about Earth-Sun relations. So proceed to the assignment on the next page. Once you're done with that, we'll pick up chapter 1.